Good morning, welcome to
Math Problems number 104.
Problems number 104. So we've been having a lot of fun this morning with continued fractions, right?
Yeah.
Yeah, so in this video we're going to take a quick look at this continued fraction. 1 plus 1 over 2 plus 1 over 2 plus 1 over 2 plus dot dot dot. Okay, so kind of like the one we did yesterday that had Fibonacci hiding inside of it.
Yeah, except the bottom is 2.
The bottoms are 2's. And we can real quickly, and then we're going to bring up our continued fraction machine in a second. We can look at what these look like at the beginning. So it's 1.
It's
If we just look at that, and then how about this one part?
It's 3 halves.
Okay, 3 halves. Now this part's a little more tricky. So why don't I stop here for how we're doing it? Okay, so what do you have to do to evaluate just that part? If I stop there,
You have to do this,
Okay.
and that's 5 halves.
okay, very good. 5 halves.
Then 5 halves over 1 is 2 fifths.
2 fifths. Okay.
And then 2 fifths plus 1 is going to be 7 fifths.
7 fifths. Okay, awesome. And that's great fraction practice, evaluating all of those, right?
Yeah.
But it turns out that,
There's a shortcut.
that there is a little bit of a shortcut that mathematicians discovered when you have that form of continued fraction. You have all these ones here up in the top. Okay? And what we do is we write our other numbers, these ones, 1, 2, 2, 2, in the top of a chart.
Yep.
1, 2, 2, 2, 2. And of course we would go on forever,
Yeah.
right? And we just put some numbers here in the beginning like that. We don't even know what those mean. 0, 1, 1, 0. And then we get our fractions by multiplying diagonally, 1 times 1, and then adding, plus 0.
1 times 1 is 1. That
Plus 0 is?
is 1.
And then 1 times 0 plus 1 is?
1.
1. So our first number we get is 1 over 1, which you see matches that, 1 over 1.
Yeah.
Okay? 2 times 1 plus 1 is?
It's 3.
2 times 1 plus 0 is?
It's
2 times 1 plus 0.
It's 3. Well,
2 times 1 plus 0.
it's 2.
2, very good.
Like we got
3 halves, just like we got. 2 times 3 plus 1 is?
7.
2 times 2 plus 1 is?
It's 5.
5. Okay.
Got that. That's
that.
cool.
And if we kept going, we can go as 2 times 7 plus 3.
And that's gonna be 17.
17. 2 times 5 plus 2 is?
12.
12. 2 times 17. Ooh, do you know what that is?
It's 34.
Plus 7 is?
41.
41. 2 times 12 plus 5 is?
It's 29.
29.
And then you can keep going that way.
Yeah, you can just keep going and going and going. Now, I'm going to show you something interesting about these numbers. Okay? So this was neat in that it helped us speed up.
Yeah.
But these numbers have lots of really interesting properties.
Ooh.
Okay? Now, one thing they have, we can watch when we multiply this way and multiply that way. Okay? 1 times 2 is?
2.
1 times 3 is?
3.
So those were almost the same, they just differed by 1, right? Now let's do it here. 3 times 5?
It's 15.
2 times 7?
14.
Ooh. Do you know what 7 times 12 is?
I think it's 84.
84. Do you know what 5 times 17 is?
I don't think it's
85. And then let's look at this one. Let's bring out our calculator. 17 times 29. Do you know what that is?
I don't think so.
17 times 29 is 493. Oops, 493 when you go that way. And 12 times 41 is 492.
It looks like they all differ by 1.
So when you do these cross products, they seem to always get very close to each other and differ by 1 somehow. Here's another amazing thing about these particular sets of numbers. What I'm going to do is I'm going to square them.
Yep.
And I'm going to multiply the bottom by 2 after I square it. So the top I get 1, 9. What's 7 squared?
49.
You know what 17 squared is?
No.
289. You know what 41 squared is?
Nope.
1681. Okay, now we're going to square the bottom and multiply by 2, okay? 1 squared times 2 is?
It's just 1.
1 squared is?
Is 1.
Times 2 is?
Well, it's 2.
2. 2 squared is?
It's 4.
Times 2 is?
8.
5 squared is?
25.
Times 2 is?
50. Hey, they all differ. They all differ by 1 when you do that too.
12, do you know what 12 squared is?
144
Times 2 is?
is 288.
288.
Hey, the bottoms are always smaller by 1.
Yeah, and then 29 squared, 29 times 29 is 841, and I multiply that by 2, I get 1682.
Wow.
Whoa! So these numbers aren't just kind of cool things to write down in our machine. They sometimes have really interesting properties.
Yeah.
This property, this cross-multiplying property, they always have. This property here that I'm showing you is very specific to this set of numbers because this continued fraction we're looking at here.
Has all 2s in it.
No, it's not because it has all 2's in it. 1 plus 1 over 2 plus 1 over 2 plus 1 over 2 plus dot 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 dot.
Yeah.
This continued fraction equals the square root of 2.
Oh, that's cool.
And we can learn how to, someday we're going to learn how to prove that.
Nice.
Isn't that neat?
Yeah.
So this square root of 2, it seems like a pretty complicated number. And then when you look at it on a calculator, you get like 1.414 and it just kind of goes on forever and doesn't really ever seem to repeat.
Yeah.
See it on the calculator?
Wow.
It's a just crazy number, right?
Yeah.
But when you write it as a continued fraction, it's really
Yeah, it's really.
simple.
Yeah.
Cool, right?
Awesome.
All right. Awesome. Continued fractions are really neat.
Yeah.
Continued fractions are very cool.